210's where we are. So 210, we're looking at some stuff here on my paper here where I gave you a sheet of notes just to save the board and save you some handwriting a little bit. What's this little -1 thing called in the trig world? What kind of trig stuff is that? Inverses. What do inverses get you? Angles is correct. So we're working today on a lot of stuff with inverses getting us angles in a variety of ways. So if you see me writing something like theta equals inverse sine of 0.8, what that means is there is some angle I could call theta that has a sine of 0.8. Trouble is this has an infinite amount of solutions. So I can use this graph to show you why. Sine, you know, looks like this. That's what we've usually graphed of sine. If I go searching for a 0.8 height, that could tell me an angle, call it A, that would have that sine be 0.8. But if I continue going and find another point over here, there's another angle B that has the same sine. There's 2. How are there more than 2? Because this graph is showing 2. How could my graph show you more than 2? Because there's actually an infinite amount of choices. What's true about this graph? Let's try this. Grab your calculator. Punch in y equals sine theta, hit graph. How's your graph on your screen different than my graph on my board? Although mine is largely correct, yours on your screen is better. Why is yours better than mine on your screen? If it looks funky, hit zoom trig. It goes in both directions for how long? Infinity, forever. So there's more on this side. I could keep tracking, and there's another angle, call it C. There's another angle, call it D. This keeps going this way. Keep tracking. There's another angle, call it E. There's another angle, call it F. There's no end to how many of these answers there are going to be. Your calculator will find you 1. This one answer is called the principal value. So this A that I found first, that would be a principal value. But there's a whole lot of other angles around town. So let's grab your calculator again, punch in, make sure you're in degree mode. So we'll set our mode to degree mode. Let's go second sine 0.8. Is that like somewhere maybe in the 50s? Yeah. What do you have? 53.1. So we're looking at a 53.1. Go ahead and punch in sine, punch sine 53.1 now. It should show you the same 0.8 that I've just been talking about. Punch in sine 126.9. What do you notice about sine 126.9? Same answer. Can anybody tell me how I made that jump in my mind? I needed you to tell me this one. I don't have that one memorized. But if you tell me angle A is anything, I made the jump here to angle B. Can anybody tell me how I made that jump? That's correct. This portion of your graph is 180. This is a little bit in, the B is a little bit back. If we take A and subtract from 180, that's always going to find you another angle. Let's grab your calculator, and I'm going to make another jump. I'm going to make a jump to 413.1. Sine 413.1, same thing? How did I make that jump? Anybody see how I made that jump? What I just found angle E.
You add 360.
Add 360. The period of this graph is 360. So if we add 360, we can keep making those hops. how could I make a hop from B to F? Now that we knew B was this, how could I hop from B to F? Any insight in that? If I know B, how could I hop to F? Add 360 again. What if I wanted to make another hop? Add 360 again. We can do this forever. Okay, so on the next sheet of notes I wrote the general solution is what it's called to describe all of the answers once we have the principal value. So for sine, the problem that we just did here, I came up with 53.1. The general solution in the degree column I wrote here, it's theta, meaning what the calculator gave you, plus 360k. So I'd write 53.1 plus 360k. And then the second half is to do 180 minus that. 180 minus this was the 126.9 plus 360k. This is called the general solution. The 53 is the principal value. Calculator gave you that one. This whole thing that's in the box is called the general solution. What this means is I could take 53.1 and add 360 once. I could add 360 twice. I could add 360 three times. I could take 53.1 and add on any amount of 360s I'd want to add on, and I could get as many answers as I want to get. This means I could take 126.9 and add on as many 360s as many times as I want to, and those are all valid answers. For sine, by the time we take a quiz, you've got to just memorize like that general solution thing. I also gave you a radian alternative. If you had a radian alternative problem, all you have to do is trade out 180s. If 180 is out, who comes in? Who's 180 tradable for? Pi. 360 is tradable for 2 pi. Okay, cosine does a little bit of a different graph. So if I wanted to use a graph just to get us rolling, if I played with the same number, cosine, I usually graph you this. So if I go looking for 0.8, that would give me like angle location A. But if I go this way, how would angle location B compare to angle location A? Because of the symmetry of that. Whatever A is, B's the same number, it's just negative. And if I want to find more things that are later on down the line on a different hump, I could just take these two starters and how did we jump ahead a hump? Add 360. So the formula that I wrote on this paper for you for cosine is we'll do plus or minus whatever the calculator says, plus 360k. Or if it's in radian town, we'll make those little like substitutions. Tangent repeats every 180. We saw that on the quiz you just did, the jackrabbit roller coaster double dip kind of thing. You get a repeat every 180. So there's no tangents in the homework tonight. There will be some tangents in the next chapter. Chapter 3 has some tangent problems. Chapter 2 doesn't acknowledge tangent. So if you don't memorize anything about tangent, it doesn't matter. Just save this sheet till chapter 3. Someday I'll refer back to it again. But tangent, you do whatever calculator says plus 180k. Add on as many 180s as you want, because tan, you probably noticed on the quiz, you had like twins, sort of. There were two of those. It doesn't take 360 to get through, it only takes 180. Question about what I'm describing here to you? Okay, tidbits. If you have a problem that ever sneaks in a negative, we're going to need to make an adjustment to the principal values before we write a general solution. So to the back. If I take the sine problem that I just did with you, and I sneak the negative into the problem, if I change that positive 0.8 to a negative 0.8, the impact that would have is it would change your 53 to a negative 53. But then you'd have to go 180 minus a negative. What's going to happen with like minus stuff? 180 minus negative makes it a positive. So this would actually be 180 plus that 53 to go other ways. Cosine, if I sprinkle you in a negative, you don't do the same thing. You'd have to take 180 minus what I gave you. So if the screen showed up at 53, you'd go 180 minus 53 to make an adjustment before leaping forward. Tan's like sine, just make it negative. Then I have a chart on here to just help us along. The chart's going to be back. We'll look at the chart in a little bit, but the chart's just there to be handy to your life with radian and degree both. If you don't have that handy, now you do. You can use this as a bookmark for another day or two, and these things will absolutely, if I had to pick one thing from chapter 2 that you'll need in chapter 3, it's this. This lesson is the one that's going to go forward the most into chapter 3. I'm going to look at some book homework and do some problems for free, but that's like the concept is inverses get you angles. The calculator can get you 1. It's a nice tool. It's a nice start. But there's a limitless amount of answers, and sometimes we want all of them, so you're going to need to memorize these general solutions. Question on things? So let's go homework page. Homework's going to be on 55, so head to 55. Somewhere I have a paper that'll tell me what to do. I'm assuming I'll start with 1. Papers, where are you? There it is. Yeah, so we're going to do number 1. So we already kind of did a problem equivalent to number 1. What buttons do you think you want to hit to do number 1? It says principal value, that means use your calculator. It says 2 decimal places, it's another tip, it's calculator time. Number 1, we just have to push button. Second sign, punch that number, hit it. If you want to try it out, I'm hoping you show up at 11.24. Anybody with trouble on 1? Cut down to 5. If right now you just punch second cosine 0.845, you're going to be wrong unless you make an adjustment. Does anybody perceive what I'm talking about for radian mode? You're going to have to switch to radian mode. So number 1, we were in degree mode. 5, we've got to pop over to radian mode. So pop your mode over, and then what are you going to hit on 5? Yeah, what's it going to show up now? Anybody answer yet on the screen? Yep, 0.5642. We're going second cosine. Hit that 0.845 in there, 0.5642. Anybody 5? Question about 5? Okay, then pop down to 9. 9 has the same start, but we're going to have to build. 9's going to have a little bit more to it. So for 9, first change your mode again, or at least look at your mode. Are we in the right or wrong mode to do 9 right now? Wrong. Okay, so here's something I suggest some years. Just maybe do all the radian questions while you're in radian mode. Do all the degrees while you're in degree mode. Instead of keeping it switch back and forth, maybe you want to just be in one mode, do half the homework, change modes, do the other half. That's up to you. But for 9, get back to degree mode. We'll go second cosine, 0.91. And what should show up is a 24.49. Does anybody have trouble getting that 24 going? Okay, then we have to look. Cosine, general formula, look at the other paper. So this is filling the role of the theta in the general solution. What surrounds the theta in the cosine general solution? Is there anything out here on the notes? plus minus, it's plus minus, whatever the calculator said, plus 360k. This is the general solution for that problem. Okay, what this means is that positive 24 is an answer, negative 24 is an answer, and we can make as many more answers as we want if we just keep adding 360 to the answers that we already just said. That's part A, the general solution, got it. B, we want to know the first three positive answers. So negative 24 is not helpful for part B because that's not positive. 24.49 is helpful because it is positive. So we're going to do a list of 30. How could we make two more? Positive 24 was on our screen. Negative 24, it was around, but we discarded it for this list because it wasn't positive. But how could we make two more answers happen? What's this telling us we can do? Add 360 to one or to either or both? Add them to both. We had a negative 24 that was valid. Add 360 to that. That's 335.51. We had a 24 that was valid. Add 360 to that. That's 384.49. The answers are also going to take turns who's friends with who. If I wanted to make a fourth answer, I'd look back at the second one and add 360. If I want a fifth answer, I'd look back at the third one. I'd add 360. If I had some crazy list and I wanted a 10th one, the 10th one would rely back on the eighth one. The eighth one would rely back on the sixth. The sixth would have relied on the fourth. The fourth would have relied on the second one. That we could backtrack. You know, if I wanted the 95th answer, the only way to get to the 95th answer, and I'm not going to talk it the whole way through, but the 95th would have relied on the 93rd back to the 91, all the way back to ultimately the first one. They're going to take turns, just keep adding 360 as we go down the line. Question about 9. Okay, let's go then down to 17. No, not 17. 9. I was going to do 19 to do a sign question. So 19, switch modes again. Second sign, 0.98. Second sign, 0.98. I'm hoping that you see a 1.37. Agree? Anybody trouble showing 1.37? Okay, then let's look at the general formulas. Okay, it's a sine, so look at the notes of the sine general formula. We also switched to radians, so look at the radian version of that general formula. How can we use this? This is representing the x now in the general formula. How do we surround that with more stuff? It says x plus 2 pi k. So what this means is instead of adding 360 as many times as we want, we're going to add 2 pi as many times as we want. And then what's the other half? So we'll go, while this is on your screen, go pi minus what's on your screen. So go pi minus answer. Pi minus answer will be a 177. And then surround that with a plus 2 pi k. It's harder to write that answer than it was cosine, because cosine, it also had 2 halves, but the plus or minus just made it a little easier to write the 2 halves. This has 2 halves, we had to do a little bit more work for it. But then you gain ground on B. How many positive answers did we already uncover? How many positives have we found? 2. 1.37 we found. 1.77 we found. So we're 2/3 of the way there on this list. Last time we had to work a little more on the list. This time a little bit less on the list. Which of those answers would the third rely on? The third would rely on first, just to add on 2 pi. So 1.37 adds on 2 pi, that's going to be 765, I think. You have a pi button, feel free to use it. So 1.37 plus 2 pi, I'm thinking, am I right, 765? Yeah. Question about any of that? Here's a what if. Okay. If I went back to this question, and the original thing had a, well, I'm not going to do that. I'm not going to do a what if. I'll hold my what if for the next section, because I retract my comment. I'm going down now to 25. So 25, it says exact. Exact means forget about your calculator and start using charts or Oscar and his apples or pictures or whatever you have. These are all going to use the chart. Okay, but calculator's out. We need to do this by other means involving drawings and trig and charts and notes and brains and things. So 25, it's just asking you to find the angle where cosine is √3/2. So for what angle is cosine √3/2? 30. If I switch my mind for an x, you'd still be looking at the same column, but not using the 30. You'd be using 5/6. If I here's my what if I retracted a minute ago. If I threw a negative into number 25, the note about negatives that's on the back top is telling you what to do with that. We were just thinking it was going to be 30. If I threw a negative into the problem on 25, for cosine, you do 180 minus 30, and your real answer is 150. If it was an x question, you'd go pi minus what we had produced, and we'd figure it out that way. Question about 25 to 30 or my what if? And let me take on, I don't know that I need to take on really anything else. I think that would do it for me. We're using the chart backward. Just make sure you use the degrees for the thetas and the radians for the x's. They sprinkle in a couple negatives. If they sprinkle a negative in on a sine question, let me go ahead and do 27. Ignore the negative at first. Sine, half, go grab an angle. What angle would we grab for sines and halves?